Infrared photography. Here are the facts. What we are doing is capturing infrared light that falls outside of our own visual range. Now, why would we want to do this is an obvious question. Well, the images we can capture generally have quite a bit of impact. And we can take these images in lighting conditions not always best suited for visible light photography. It's also a fascinating and creative area of photography that's become much easier with digital cameras, but I agree it can sound a little bit like some black art. It really isn't though, and that's why I've made this video. So how do we capture these infrared black art images? The only practical way is to have a camera converted, which means we have to dedicate a camera body to this process. It's our first hurdle, perhaps. So what does this conversion of a camera consist of? There's an infrared blocking filter in front of the sensors in our camera. A technician removes that filter and replaces it with a red visible light blocking filter. The result is we have a camera that shoots infrared and we can handhold that camera as normal. Now, it's often said that you don't really need to have a converted camera at all to shoot infrared. That all we really need is a red filter on the lens. Now, the red filter in question is something like an R72. It's deep red and it'll block visible light. And then you can shoot the infrared light that falls onto the camera's sensor. Now, I've tried this method, and in fact I do have an R72 filter sitting on my bench gathering dust, because we soon run up against very practical problems. If we remember that all cameras have an infrared blocking filter on the sensor, if we put then a visible light blocking filter on the lens, the shutter speeds we're going to need are going to be extremely low, which means you're going to require a tripod for practically every shot or a ridiculously high ISO. The other thing to bear in mind is the red filter is so strong that we can't actually see through it, which means we need to frame up without the filter, then screw on the red filter before pressing the shutter button, which means we need a tripod again. Now, I had a Canon 5D converted to shoot infrared in 2014, and I'm still using that camera regularly into 2023. The lens I use with it for 99% of the time is a Canon 17 to 40mm wide-angle zoom, and for the rest of the time I have an old Canon 28 to 135mm. Now, I don't think colour has ever been easier to apply to monochrome images than it is today. Adobe's neural filters are perfect for our needs. Strategic colour also offers a fair degree of impact too. Now, here I've got a typical infrared image from my converted 5D camera, just to show you there's no complications with the editing. Now, it's always very easy to add contrast rather than remove it. So the lower contrast of infrared images works in our favour. Editing isn't difficult or demanding. In fact, it's pretty much the same as all the rest of the image editing we're likely to do. Check out the more details below, and I'll link to videos that are relevant to this one, like neural colorized filters in Photoshop. I'll also list a couple of contact points for camera conversions, one in Australia and another in the UK. Because our camera's light meter is not calibrated for infrared photography, select a manual exposure, but along with that, set up a 3-image automatic exposure bracketing with one stop between each shot. Now I found that if I set the exposure at 125th of a second at f8, I get that plus one stop either side, and that's met my needs 90% of the time. If you also set your drive to continuous in conjunction with the automatic exposure bracketing, you can just frame up, focus, and fire off the 3 shots automatically. Infrared has kept my interest now for 8 years plus. If my camera come to the end of its life, I think I'd have to replace it with another infrared. I'll see you next time.